Ha! We're back. Uh, is he bothering you? Yeah, you get out of here. Let's see. Where were we? Oh yeah, we're doing the final. So next question, you had to divide. Another decimal division problem. This one I kind of started out already. So it would look like this, and then we're going to have to move the decimal point over. 1 position. And then we go, how many 42s can I get into 1? None. 7, none. Notice I can't get some 42s out of 178, and I can get 4. I put it right above the 8. 4 times 42 is 168. When I do that subtraction, I have 10. I bring down the 7. And I can only get 2 42s out of 107. So 2 times 42 is 84. When I do the subtraction here, I have 3, 23. Now I have to bring down this 5. How many 42 is going to get at 235? Well, first of all, let's bring the decimal point out. If I say 6, that's 240, which is too much. So I'm going to say 5. 5 times 2 is going to be 10. Carry the 1. 5 times 4 is 20, plus the 1 is 210. That's subtraction. That leaves me with 5, 2, and I bring down this other 2. How many 42 is going to get at 252? Well, I'm going to try 6, because 6 times 4 is 24, and the 2's. 6 times 2 is 12. Put down the 2, carry the 1. 6 times 4 is 24, plus 1 is 25. Bada bing, bada boom. Done. So 178 and 752 thousandths divided by 4 and 2 tenths is 42 and 56 hundredths. So excuse my 56 hundredths there, which is D. Number 11. Evaluate A times the quantity B plus C for the values of A equals 4 and 4 tenths, B equals 3 and 5 tenths, and C equals 2 and 7 tenths. So this is simply a case where we're going to actually have to plug in some values. So A is 4 and 4 tenths. That's my A. B is worth 3 and 5 tenths. Plus C is 2 and 7 tenths. Well, order of operations, right? I do inside the parentheses first. 3 and 5 tenths plus 2 and 7 tenths. It's going to be 6 and 2 tenths. 3 plus 2 is 5. 5 tenths plus 7 tenths is 1 and 2 tenths. So 5 and 1 and 2 tenths, 6 and 2 tenths. So I have a problem here that looks like 44 times 62, except I just have the place values, right? One place value, one place value. So I'll wind up moving 2 place values when I'm done. 2 times 4 is 8. I'm going to get the same thing again. 8, put down a 0. 6 times 4 is 24. Carry the 2. 6 times 4 is 24, plus 2 is 26. I get to add these together now. Yay! 8. 8 plus 4 is 12. Carry the 1. 1 is 6, 7. So I have 2 place values to move, right? I have to add up the place values. So I start here. I'm going to have to move over once, twice. Final answer, 27 and 28 hundredths, which is problem answer B. Next question. Well, here I have to draw the box and whisker plot, or actually identify the correct box and whisker plot from those selected. So I have some data here, and notice conveniently it's already in order. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. So I do have a middle piece of data, which is 1, 2, 3, which is 6. So I know the median is going to be at 6. So right away that puts, I know it's not B, and I know it's not C, because the median is going to have to be at 6. Both of them, this one here is a little suspicious, because the minimum is a little bit lower. It seems like it's not quite lined up with the 3 like this is. And I know I have a minimum's 3 and my maximum's 9. But if I look, I can see that this has a lower quartile of 4.5. This has a lower quartile of 7.5. This has a lower quartile of 4.5. This is just a little bit more than 7. But it's definitely not 7.5. If I look for the upper quartile, it's going to be between these two values, 7 and 8, which is 7.5. So that means this is the upper quartile matches best, and none of these others do have both a median at 6 and the upper quartile at 7.5. So the correct answer here has got to be D. So 13 was D. 14. Which expression does not equal 24? This question sounds familiar. Well, I just have to simply plug in the value and check. So for 14, if I do A, I'm left with 4 times 5 plus 5. Well, 4 times 5 is 20, plus 5 equals 25. Hey, that is not 24, and that answers the question. Which does not equal 24? Well, that doesn't equal 24. The others, 3 times 10 would be 30, and 30 minus 6 would be 24. If I plug in here, 3 times 10 is 30, divided by 2 is 15, and 15 plus 9 is 24. If I plug in 3 for B here, 3 times 7 is 21, and 21 plus 3 is 24. So A is your correct response. Number 15. Given the expression 4n squared and the value n equals 3, let's get this up here. Given the expression 4n squared and the value n equals 3, which of the following is a correct reading of the expression? So before we go through the answers, let's look at this real carefully. 4n squared, n equals 3. So in this case, here's my n, it's 3. So what this is saying is 4, whatever 4 is, I'm going to multiply it by this n squared, which in this case is 3 squared. So what I have here is I have 4 times 3 being multiplied twice. I could say this a number of different ways, but this is what I have here. So which of these matches up? First, multiply 3 2 times, then multiply the result by 4. So first multiply 3 times 2. So that's same, A is same. Multiply 3 times 2, and then multiply that by 4. That doesn't match. 3 times 2, and whatever that result is, times 4. That's not right, so A is not right. B says, first multiply 4 times 3, then square the result. And that looks nothing like this. I suppose what we should do is we should multiply these out and see what we get. 3 times 3 is 9, times 4 is 36. So the real answer should equal 36. Well, in this case, in A, 3 times 2 is 6, and 6 times 4 is 24. So we see that doesn't work. In B, 4 times 3 is 12, and 12 squared is 144, so B doesn't work. C, first multiply 3 times 3, then multiply the result by 4. Now this is looking more like what we wrote up here, right? 3 times 3 is 9, and 9 times 4 equals 36. So that matches. Let's check D. First, add to it. Well, just because it says add, that we should ignore that. So here's our correct answer. Correct answer is C. Last problem. Draw a dot plot for each data set. So I have some values here, and I just have to match it up with the graph. So if I look at the graphs, is there some way for me to identify anything that's unique? I see 3 of the plots have a 21, or no, 3 of the plots have 21, and there's a 21. But only this plot also has a 20. Is there a 20? Ooh, there you go. There's a 21 and a 20. So that's looking suspicious that C is right. C has 1, 2, 3, 4 values at 13, and there's 1, 2, 3, 4 values at 13. There's two 14s, one value of 14, two values of 14. And then there's a 15, a 16, a 17. There's a 15, a 16, and a 17. And then we're left with a 20 and 21. So the correct answer is C. There you go. That was the final. Let's see what happened to Mrs. McCabe. So she called all her sons all at once, and you can imagine it was kind of a mess. So all 23 Daves come on the run. What would that look like? This makes things quite difficult at the McCabeses, as you can imagine, with so many Daveses. And often she wishes that, when they were born, she had named one of them Bodkin Van Horn, and one of them Hoosfoos, and one of them Snim, and one of them Hot Snot, and one Sunny Jim, and one of them Shadrach, and one of them Blinky, and one of them Stuffy, and one of them Stinky, another one Put Put, another one Moonface, another one Marvin O'Gravel Balloonface. How'd you like to be named Balloonface? One of them Ziggy, and one Soggy Muff, one Buffalo Bill, and one Buffalo Buff. One of them Sneepy, and one Weepy Weed, and one Paris Garters, and one Harris Tweed, and one of them Sir Michael Carmichael Zut, and one of them Oliver Bolivar Butt, and one of them Zanzibar Buck Buck McFate. But she didn't do it, and now it's too late. Poor Mrs. McCabe.